So I'll be discussing water quality optimisation today. We'll be talking about turbidity, chlorine contact time, and water quality monitoring. So first up is turbidity. So Cambodian Water Supply made it known to us that their biggest challenge is turbidity at the offtake pump. They have a number of sand mine industries upstream that continually backwash sand back into the river, which goes straight down to their offshore pump. They're pulling water off the Chlorine river, and they're getting turbidity levels in the dry season up to around 600, 700 MTU units. So there's high levels of solids in the water. It's having an effect on their treatment plant by severely minimising its performance. We're seeing severe loss of revenue as a result of increased dosage requirements, both PAC and chlorine, and increase in maintenance requirements as the high sediment load damages equipment and continually causes block-ups. So after discussion with the water supplier in Melbourne, which is Melbourne Water, we came up with the idea of potentially using a silk curtain to minimise the amount of turbidity in the system. A silk curtain is generally designed to control the transfer of silt in aquatic systems. And in Australia, they're commonly used in dredging and offshore construction to minimise the amount of waste that's going into the marine environment. They work not as a filter. They promote sedimentation by stopping the horizontal transport of sand and turbidity. It allows it to then settle down to the bottom of the water column and makes it for clearer water downstream. So yeah, again, Melbourne Water use these in Victoria. They use them at Sylvan, which the teams came over and saw when they were over there. They use them at Sylvan to minimise the amount of turbidity infiltration from Upper Yarra, which is the catchment that leads into Sylvan. And they've also used them at Thompson Reservoir as well. We've recently had bushfires in the summer period, and there was a great concern of a lot of sediment and ash being possibly washed into the catchment if a high rainfall event happened. So they were proactively used to make sure that we wouldn't have turbidity issues in the catchments. So that's a picture there. So after we decided on the idea, we put the idea out to the companies in Australia that specialise in silt curtains. Trade Environmental came back to us with a proposed dual net system. The first net to deflect the strength of the river, the second net to go across the mouth of the offtake lagoon to create a really stable water column to further promote turbidity dropout before it even got to the curtain across the lagoon. So we asked Cambodian to produce a depth profile for us. We needed to know how long the silk curtain needed to be, how deep, and what kind of environmental conditions the curtain would be placed up against. So this was our initial design here. We've got the preliminary curtain further out to the river. The idea was we were going to anchor it in place using river anchors to make sure that the strength of the current didn't push the curtain in towards the lagoon. And we had the curtain across the inlet to the lagoon anchored with land anchor points. So there was quite a lot of work that needed to be done prior to us getting there to help with the install. Cambodian were really good. We asked them to install land anchors. They needed to be strong, sturdy, and they had to be heavy enough to make sure that in the wet season the curtain wouldn't get washed away with the increased flows. River anchors needed to be attached direct to the curtain, which they got ready for us. It's important to note that if you are interested in this material to be used, you can't attach an anchor directly to the curtain. it'll place a lot of strain on the curtain material itself. It's better to apply an anchor to a buoy and just use a tether line to the buoy to keep it in place. And this all needs to be done prior to installation day. So Untitled was very good with his communication and helped us out a lot. So we asked for photos leading up to the install to make sure everything was going away well, or going well. Untitled sent us photos, and we noticed that the water level was quite a lot higher. We didn't take this into account in the initial design, so we got back to Trade Environmental and asked if this is going to be an issue. As the curtain itself is 2 metres in depth, and the river will go up and down 2 metres in the wet season and the dry season, there is a risk that during the dry, the amount of sediment that's dropping out of the water column could weigh down the curtain on the riverbed, and when wet season comes around again, the curtain may not come back up if it's being weighed down by the sediment. So we just had to make sure that we applied the maximum buoyancy to the curtain to make sure that it will come back up, and hopefully we won't see that issue. So that's an example there of the dry season on the left and the 2 metre change in level on the right. So this was installation day. AWA was very graciously helped us out with making sure that the curtain was going to be there on time, and we got to work straight away. So this is day one. We've got land anchor points just to the left of the screen, and there's another land anchor point onto the right. But not everything went to plan. We realised that one of the curtains, the one that was going to be across the inlet to the lagoon, was the right size, but the one that was going to go out into the river to create calmer water was undersized. So we had to think on our feet and come up with a solution very quick. We also realised at this time that there was another source of water infiltration into the lagoon. We originally thought that all the water was going through the mouth of the lagoon, but water was also getting through here as well. So we ended up connecting the two curtains together, and so now they're running from one side of the lagoon all the way around to where solid land connects back to the bank on the right hand side. It's important, we also have to make sure that we allow enough slack on the land anchor points. With a 2 metre change in river height, you need to make sure that the curtain can rise and fall with a change of conditions. So we allowed the extra slack with chains connecting the curtain to the land anchors. We didn't attach the curtain direct to the anchors. We also began discussions with chlorine contact time. When the crews came out a few months ago, we had a chat with Melbourne Water at Tarrago Reservoir, and we realised that understanding of chlorine contact time as a treatment process was very much in development. For those that don't know, chlorine contact time is a disinfection standard that's used in Australia. Essentially, it's just the residual chlorine times the time that the chlorine is in contact with the water. It's so important because it makes sure that pathogens that could make it through the treatment plant process don't reach the customers. It's used for all drinking water treatment plants in Australia. To develop your own required chlorine contact time, you need to know the pH of your water, the temperature of your water, the pathogens in your source water. So source water analysis would be required to figure out what pathogens are present and at what volumes. And then you'll need to consult the literature to figure out what contact time is required to ensure that you are removing 99.99% of whatever pathogen you are trying to remove. And as long as your CCT or chlorine contact time is greater than that required in the literature, you have met the specification. So that's how we equate chlorine contact time there. It looks a bit confronting at first, but it's not too hard. It's just chlorine residual using your lowest operating volume of your clear water storage, your maximum flow rate out of your storage, and then if you have any baffles in that storage. So easy steps. We didn't expect that the crews would be able to adapt chlorine contact time into their treatment process straight away. So we gave them the first steps, which dosing at the inlet of the clear water storage is the most critical. Dosing on the outlet does not allow for any disinfection before the water actually goes out to the customer. And also maintaining a consistent strength, knowing how much chlorine you're actually dosing into your supply and knowing it and keeping it the same, so that measuring, you know the effectiveness of your treatment plan. So that's an example there. You don't want to be dosing chlorine at the outlet. You want it to be going into the inlet, as it then has time to mix in with the water in the storage and remove any pathogens that might have made it through the treatment plant process. So at Beckchan, we noticed that the chlorine dosing plant at their secondary storage was going into the same pit that the outlet pumps were pulling water from, essentially not allowing for any mixing at all, and just sucking the chlorine straight out into the network before it actually does its job. Within 24 hours of giving them the suggestion, they had already moved it to the inlet, so that was great to see. This is Crouch Mars dosing setup. They dose at the inlet. They have a small dosing tank, which then feeds into the clear water storage. And Kompong Chom Long at the same kind of setup. The other easy thing to implement in your treatment plant is a baffle factor. So a lot of you may have clear water storages that are just big tanks, nothing inside them. A baffle is a blockage. You're trying to minimise the amount of short circuiting that takes place in the tank. In an empty tank, the majority of the water will just short circuit from the inlet directly across to the outlet, and you'll end up with very old stale water in the rest of the tank. Increasing baffles will proportionally increase your CCT, and it's not a costly thing to implement. So we discussed this with all the crews out on the treatment plant sites. This is an example of Crouch Mar, where they've got two chambers in their clear water storage, and the outlets are pulling off the left and right of the storage instead of the back. So you've got a bit of short circuiting towards the pump station. That can easily be fixed with one baffle in each chamber. Another thing that we try to implement in our visit is actual water quality monitoring. It's incredibly useful. We use handheld instruments at Southeast Water. They're essential equipment for field crews. They're cheaper than online alternatives. They're portable. But for applications in Cambodia, they can also be very useful instead of using online monitoring equipment. As long as they're being used every day, multiple times a day, they're still going to give you important information about how effective your treatment plant is performing. You can use chlorine, turbidity, temperature, pH, electrical conductivity, or total dissolved solids is what you're probably using. And they can also be used to verify the accuracy of probes if you then go into online monitoring. So there are examples there of measuring turbidity in chlorine. And this is a ledger that we saw at Kompong Chong Long. It was the first one we've seen of actual record keeping. It was very good to see. As long as some records are being kept, then you're going to be able to identify whether the treatment plan is working the way you want it to be working. if all you're doing is using the outlet water, whether it's clear or not, as your justifiable variable for performance, you're not getting the whole picture of your performance of your treatment plant. So the next step, and what we've seen in a lot of the plants that we've visited, is the more established companies are starting to go towards online monitoring. It's generally the trend. You need to get revenue from your water supply before you can start investing in your water quality. It would be nice if you could do both at the same time, but unfortunately you've got to get the water to the customer first, and then you can start investing on ways to improve. But online monitoring provides real-time data on variables at your treatment plant. Similar to a flow meter, it will tell you at any time of day, and if you check it once a day, you'll be able to see how your treatment plant is performing, how your chlorine dosing is performing, how your turbidity is performing. But it is dependent on a stable power supply, unless you utilise batteries or generators to kick in. And you do need electrically trained technicians to install it. Kampong Chong Long have started integrating online monitoring into their treatment process. Unfortunately, they weren't trained correctly on how to maintain the system, which is essential. If a water authority decides to go down the route of bringing in online monitoring technology, you need to invest on training and staff to maintain the equipment, to calibrate the equipment. Otherwise, you're at the mercy of the supplier to help you if something breaks. So, going forward, how do we verify the performance of everything that we've applied in our short visit? Has the silk curtain actually reduced turbidity? We've had a discussion with Beck Chan, and they're actually seeing 40 to 50 turbidity unit decrease in the water at their offtake lagoon, which will have significant effects on their pack dosing requirements. Revenue tracking. Are they spending less money on maintenance? Are they spending less money on chemical? Has maintenance costs decreased? Are things breaking less frequently? Jar testing. Do you still need to be using the same amount of coagulant as before? And chlorine dosing. Typically you'd expect to see improved chlorine residual in your network if the organic load in the raw water has been reduced.